All right, so thank you for coming. I'm here to talk to you about MariaDB and Cassandra interoperability. So if you are using MySQL today, this is a good path for you to also migrate to Cassandra from your existing installations. MariaDB is a branch of MySQL, and we'll go into a little bit about it. And I'm Colin Charles, and a little bit about me is I work on MariaDB today. I used to be from MySQL. I used to hack on MySQL code and then joined Sun when they acquired us. I've been working with open source for a very long time, from the Fedora project at Red Hat, as well as OpenOffice.org. It's probably important to note that Monty program, the company that you would see me representing today, is a major sponsor of MariaDB, but MariaDB is governed by a foundation. So it is an open source project with an open source foundation backing. And the reason why I say that I now work at SkySQL is because SkySQL and Monty program have agreed to merge towards the end of April, so we're going to be a much larger company offering services as well as engineering. Monty program was a completely engineering-oriented organization. We focused on making a better MySQL with lots of links to other databases. So today's agenda is pretty simple. I'm going to focus a little bit on what MariaDB is, a little bit about the MariaDB architecture, and you'll understand why I don't say MySQL after a while, because there's one particular feature that we've extended in MariaDB that isn't in MySQL. So for you to then fully migrate off MySQL, you'd probably have to migrate to MariaDB first because of this one particular feature that allows us to connect to other things. Talk a bit about mapping. Use cases, we've run some benchmarks as well on Amazon, and some conclusions. How many of you here use Amazon for your deployments? EC2, okay. So, since only one person here has heard of MariaDB before, what is it? MariaDB is a community-developed, feature-enhanced, backward-compatible version of MySQL. It is a 100% drop-in replacement to MySQL. If you are running Linux, like Fedora or Ubuntu or SUSE, lately, many of them, when you just do a yum install or a zipper install and ask for MySQL, you're getting MariaDB by default. So it's a new default. And we have a whole bunch of enhanced features. You don't have to deal with Oracle in terms of getting Oracle Enterprise. You can get the thread pool for free. A thread pool is very useful for many short-running queries that happen typically with your web apps. So you can just open up a few threads to run many queries and get results coming back in the same thread. We have things like table elimination, which is the basis of anchor modeling. If you are a MySQL user, you know that you cannot use subqueries. However, with MariaDB, subqueries now materialize, and there are DBT3 benchmarks showing that we can now run the full DBT3 dataset, including subqueries. We've done a huge amount of changes in replication, which still don't match the ease of use that you get out of Cassandra. So you still can't do things like multi-master replication yet. But we've made things like group commit in the binary log happen, which means that if you have more than 3 parallel running queries, instead of calling fsync every time, you call fsync at one go, at which point you actually get great performance improvements because fsync is expensive in Linux. We've also been playing a lot with these NoSQL and links. Handler socket is a NoSQL interface to InnoDB, the storage engine, which allows you to do simple create, read, update, delete operations. It completely bypasses the SQL layer. So it just goes direct to the engine, and it's very, very fast. We also integrate with the Sphinx storage engine so that you can now do full text search using Sphinx, because MySQL or MariaDB isn't really made for full text search. We'll allow multi-source replication. So since you're probably, if you've come from a MySQL world, you have many groups of little masters and slaves, but you maybe want to aggregate all the data from all those masters because they're running separately. And that's what multi-source replication is useful for. And dynamic columns we'll talk about when I get to the slide. So this is the MySQL/MariaDB architecture diagram. You have your application sitting all the way at the top. You then connect to it via the myriad number of languages that are available. So take your pick, Perl, Python, Java, etc. It then goes to a connection pool. The connection pool will then do authentication. We've extended authentication, so now that you can also do authentication against PAM. You can also do authentication against LDAP. You can also do authentication against Active Directory. After you go to the connection pool, you hit the SQL interface. Then it pauses it, hits the optimizer. It may already pick stuff up from a cache, but if it doesn't already have it in cache, it goes straight down to the pluggable storage engines. And the pluggable storage engines sit right on top of the file system. Things like MyISAM do not offer transaction support, but it's very good for quick inserts. InnoDB is fully transactionally aware, but we ship something called ExtraDB, which is InnoDB that generally runs at Google and Facebook, so it's InnoDB that runs at scale. So if you're familiar with MySQL, you're probably familiar with the Pacona toolset, and ExtraDB is a Pacona-based tool. But we've always had engines that spoke not only to the local file system, but over the network. NDB was an engine that it's always been a network database. It's commonly referred to as MySQL cluster. Federated X was commonly embedded inside Cisco routers. It would allow you to have SNMP log data sent across the wire to your MySQL server. We have an engine that now integrates directly to LevelDB. LevelDB is a key value store. How many of you use the Chrome web browser? Okay, most of you. The version of LevelDB that sits inside Chrome is what implements IndexedDB. So technically, you've been running at LevelDB without generally even knowing you have this database sitting there. It's part of the HTML5 spec. Each browser implements it differently as well. Firefox uses SQLite. Cassandra SE, that's the engine I'm here to talk to you about. That actually, instead of hitting the file system, talks directly to a cluster of Cassandra that you are very common with. I'm sure most of you here use Cassandra. Who here does not use Cassandra? Okay. Oh, okay, a bunch of you. Hopefully after this you will use Cassandra. So with the storage engine layer, we've been extending it, and we're looking at many different storage engines, including things like engines to MongoDB and so forth. So you can use the same SQL interface that allows you to now speak to other databases. But then we also extended the replication API. So now there's a replication API. In MySQL, you have binary logs, which is we call bin logs. So there's now an API, and you can have a Hadoop applier that writes directly to HDFS, which from what I understand is also kind of useful to folk. And this is not something we ourselves developed. Oracle has also worked on this as well to make this applier happen. So now you have two ways to connect to different engines. You have the replication API as well as the pluggable storage engine API, both of which generally quite unique to the MySQL world. The MongoDB world is getting the idea of having a pluggable storage engine as well, but the only other open source database that has something pluggable is a pluggable optimizer in Postgres. And we're really focusing on becoming a data platform. Yes?
Back up to the slide.
Yep.
So maybe you haven't explained this yet. Just looking at this diagram, I don't understand why would I go through all those layers and in the end just get to Cassandra and not just run Cassandra?
Okay, so actually I tried to explain the whole MySQL architecture. You don't go through any layers. You basically still write SQL to connect to your Cassandra cluster. And there are some use cases for why this may actually be useful, especially in terms of user tracking and so forth. So you don't actually go through all of this. This happens in less than a microsecond, possibly. But I kind of needed to explain what the architecture looked like so that you know how we're connecting to it and there's no black magic of voodoo happening. Because if I told you your application could just write SQL and connect directly to Cassandra, then you may presume I'm lying to you.
That's the answer.
Yeah, that's the answer. I didn't want to, I wanted to show you how we're doing it as opposed to, hey, magic happens in the background. Yeah. And we're really focusing on this whole idea of becoming a data platform, so we want to go away from the MySQL but still remain 100% compatible with it. So we have not only handler socket, we have memcached access directly to InnoDB. So if you're using memcached, which is really, really common if you have a web app nowadays, you might want to make it persistent inside, and you can save your memcached information inside NDB. So we've got the Hadoop apply, LevelDB, Cassandra, and this list is planning to go on and on. We plan to integrate with other storage engines so you can continue writing SQL without, so your current knowledge of SQL will not go away. So this is the reason why I did not mention MySQL, because we have extended MariaDB to include something called dynamic columns. Dynamic columns allows you to store a set of columns for each and every row in the table. It's an arbitrary store, and it's like a blob. It stores it in a blob, but it comes with lots of handling functions. So you can do dynamic column get, create, add, delete. And most recently, we can also give you the rows in JSON format. And JSON seems to be a relatively good interchange format that's very commonly used for many new systems. Many people like to write JavaScript from the get-go, so now you can get stuff in JSON as well. You can nest dynamic columns as well, and you can also name dynamic columns, and you do that by having a column name. Previously, you could not name dynamic columns. These were actually given to you by MariaDB itself. Now, this particular dynamic column feature is not available inside of MySQL, so the connection to Cassandra would not be available via MySQL. You'd actually have to use MariaDB. But lucky for you, if you're already using MySQL, the upgrade to MariaDB is really easy. You can just do yum install MariaDB server, and it will just replace it in C2. It reads the same data files. It has the same socket, same port number, so your application doesn't actually change per se. So the upgrade is in C2. You just generally get all the additional benefits and performance fixes that we have. So for the few people that don't use Cassandra, this is kind of like how we mapped it. Column families are exactly like tables. We have the row key to column mappings. We do not support supercolumns, but from what I gather in the Cassandra world as well, supercolumns are going away. So it's not really a big deal that we do not support supercolumns. Here's a quick example. I know it's really, really small, but this is what CQL is basically, which you should be quite familiar with. I created the key space with MariaDB test, and then I also could select it from CQL. But then you'd realize that you can't do everything with CQL. There are some select operations that do not work. CQL3 is likely to improve this, but I have a quick question here for the audience. How many are using Cassandra 1.2? How many still use Cassandra 1.1 and before? Okay, so that's more still on the Cassandra 1.1. So that's good, because this implementation is based against Cassandra 1.1. Some bugs is 1.2. So CQL looks like SQL at first glance. It, however, doesn't do joins. It doesn't do subqueries. However, MySQL doesn't do subqueries either, so you're probably already used to not having subqueries. But MariaDB does, which is why I bring that up. You don't have group by or order by inside of SQL. CQL. CQL3, I'm going to attend the talk later to learn more about it. It's relatively new because I think it only got released in February of this year. So there are still some changes that we haven't made to make it more SQL3 ready. Where clauses need to be represented as index lookups. Our simple goal today for the Cassandra Storage Engine is to provide a view into Cassandra's data from MariaDB. That means inserts, reads, etc. But we don't want to replace CQL. And we want this to be a good path for you to currently use and access Cassandra without having to use CQL yet. But maybe down the line, if you are re-architecting your application or your data model, you can then use this as a stepping stone to migrate as well. Not that migrating helps me. Getting started is really, really easy. We released MariaDB 10.03 yesterday. So this slide used to say 10.02 right up until yesterday. So you just download it there. We have binaries available for all forms of Linux. I'm presuming you are going to be testing most of this on some form of Unix. you need to load the Cassandra plugin. All storage engines are plugins at the end of the day. This is even true for InnoDB and so forth. You can do install plugin Cassandra, so name hcassandra.so. This will install it. You can also start it in my.cnf. So under the MySQLD section, you make sure the plugin load is there. Or if you install it via Linux distribution, make sure that you install MariaDB-Cassandra Storage Engine. Because if you don't install that particular package, when you run show engines, it will not be there. Also make sure that the Cassandra Storage Engine is there. You can do that by doing something like show plugins or show engines, both of which will work just fine. If you don't see this here, it means that you have a problem and Cassandra you cannot access Cassandra. Now you can create a SQL table, which is basically a view into a column family. You need to set the global thrift host. You can also set the thrift host per table. So we did this on Amazon, so you can also try this on Amazon, and I'll show you how later. I'm not going to do a live demo on Amazon because the internet's kind of flaky. And you need to create a table, specify that the engine is Cassandra, make sure that there is a key space. You must have a thrift host, because this uses the thrift API, and you must have a column family name as well. The Cassandra default thrift host, which is right up there, allows you to repoint the table to any different nodes dynamically and not change table DDL as well when Cassandra's IP changes. So this is also similar to how you'd connect to Federated X or Sphinx SC or any network-related database from the MySQL world. You always end up specifying addresses or pools of addresses, so to speak. There are potential issues that you may face, though to be fair, I ran this against 10.03 yesterday as well, just to make doubly sure that you would not have a problem. Potentially, if you run on Fedora or RHEL, you have SE Linux issues, or if you're on Ubuntu, you have audit D issues, so you may see a permission denied error. You can turn SE Linux off or stop audit D. Again, none of this happened, but if it does happen to you, which is occasionally reported, you can turn SE Linux or audit D off. With regards to Cassandra 1.2, which is what was released sometime in February, column families without the compact storage attribute are generally not supported. You'll get an error. So this is pre-CQL3. You need to use compact storage. And this is referred to as legacy tables currently in the documentation. So my suggestion is to continue making legacy tables with compact storage. We will fix this in future releases, but the time frame from February to June is still pretty short. Also, we noticed that thrift-based clients can no longer work. It also broke PIG in 1.2. And we're looking forward to the patch. The issue is Cassandra 5234. And that should be fixed probably in the next release as well. So PIG 0.11, I believe, is also broken against Cassandra now. So for all intents and purposes, I have used Cassandra 1.1, DataStakes Cassandra 1.1 for this demo. And the best part is now you should be able to access data. You can get data from Cassandra just by doing a select, and you will actually get the data pulled out of Cassandra. You can insert data into Cassandra, and then you can double check with CQL/SH to see if the data has been inserted as well. So you now have a complete window/view into Cassandra. All these commands will work in the examples, in the example AMI that I show you later. You can download it yourself. Okay, so let's talk a little bit about data mapping. MariaDB's table will represent Cassandra's column family. You can use any table name or any column family equals something to specify a column family, and this is highlighted up there. All tables must have a primary key, and the name or the type must also match Cassandra's row key. Also, columns will map to Cassandra static columns, as highlighted up there. So don't forget that the name must be the same as in Cassandra. The data types must match, and it can also be a subset of column families. That also works. This is the data mapping. We support pretty much everything, including timestamp, and we support microseconds and timestamps. MySQL doesn't support microseconds, we do. So that's probably one additional little feature there. So, what is dynamic columns? Going back again, mainly because, why do we have dynamic columns? So that we can access Cassandra's dynamic column families and access adult columns. This is how you use dynamic columns as well inside of MariaDB. You don't have to use it with Cassandra. You can use this with your regular app as well. But this is an example of how I use it with Cassandra. So I've apparently been told I have about 5 minutes left, so we're going to go a little quicker. All data mapping is safe. Cassandra SE will refuse incorrect mappings. It will actually spit errors out at you, and these are common errors that you can get spat out at you. We've mapped most commands. Cassandra has put, get, and delete. And then there are SQL commands, like select is basically equivalent to a get or a scan. Insert is basically put. An upsert is an update, then an insert. An upsert is a valid term nowadays, it seems. So with regards to select command mapping, MariaDB has a SQL interpreter. Cassandra SE will obviously support the lookups. You can now join between Cassandra tables as well as MariaDB tables. And we have something called batch key access joins available. And batch key access will actually make sure the join buffers are accumulated. And interesting columns and rows are actually transmitted to the optimizer. Turning on batch key access gives you great performance when the query sizes go from 1 to 3. So regular joins versus batch key access joins are amazing. So I'd always turn this on, especially if you're using Cassandra, because it's accessing stuff over a network. So with regards to DML, insert does overwrite rows, update reads, then writes. So let's just make it clear that Cassandra SE doesn't make it SQL. It's SQL-like, but it's not SQL per se. So a few use cases for Cassandra SE. Log collection and analysis is amazingly used inside of Cassandra. In the old days, maybe in 2007 or so, you'd say, hey, grab log data and keep this inside of MyXAM or the archive storage engine. Cassandra is better at it. Form versioning, Cassandra is better at it. You want to collect web page hits. You want to collect data from sensors. If you in the previous talk, data from sensors, Cassandra is awesome for this. So collecting the data, the time series data from Cassandra, and then querying it out using MariaDB is fine. So if you are getting time series data, you're doing user activity tracking. So this web page was last viewed by Foo. Last known position of this user inside this web page was this. So if you're an e-commerce shop, knowing the last known position of the user and keeping data of the user is very important for you. You want to keep all this data in Cassandra. It's not so good being kept inside of a relational database like MySQL or MariaDB. You are user 5 out of 1 million. The old adage was people do select count inside of MySQL, inside forum software, and that makes forum software notoriously slow, so nobody does that. That's the kind of stuff you can do with Cassandra. And if you're coming from MariaDB and you want a table that is auto-replicated, MySQL and MariaDB do not do auto-replication. You want fault tolerance and you want something that's really, really fast, get Cassandra with a Cassandra SE table. The other thing that's pretty unique is you can get a globally replicated table. Cassandra allows this, and you can't do this even with something like a Galera cluster, which is another product line that we have inside of MariaDB. Another possibly unique use case is that we have a Connect storage engine, so you can now connect and join data between an Oracle database via ODBC, Cassandra, your Cassandra cluster, as well, and use InnoDB as an intermediary and store data inside of MariaDB. You want to turn on something called engine condition pushdown, which basically sends non-matching rows from the storage engine to the SQL layer, and it does avoid round trips over the network, basically. And the filtering is done on the remote data node as well. This is kind of useful, especially if I heard people wanting to migrate out of SQL Server. Even SQL Server supports ODBC as well. And this is great use for being middleware software that helps you migrate. Non-use cases. Things like huge sift-through data joins, pig is better. You want to do a bulk data transfer, Scoop is better. Do you want a replacement for InnoDB? Cassandra SE is not quite your replacement for InnoDB. That would be rethinking the data model entirely to make it happen for you. Here's a quick, tiny benchmark. We did this on Amazon EC2 with M1 large nodes. The bottom is InnoDB in blue. You can see that the moment we even add two nodes for Cassandra, you start seeing amazingly good throughput, which is the kind of black one there. There's amazingly good throughput for data with next to no tuning when you start having a Cassandra cluster in the back end. Cassandra is really, really fast. Same setup as before, with some tuning done with InnoDB, and again with one Cassandra node, the red shows that the red beats the blue in terms of transactions, even when you hit client threads. So Cassandra is fast. Cassandra SE, the interface is really, really fast. Oh, this is for single line inserts. Both are for single line inserts using sysbench. So you can basically peek a data from MariaDB into Cassandra. It's really, really easy to set up and use. We want to see if you want other features like table discovery. We can actually have assisted table discovery of a Cassandra cluster like we do for Federated X and Connect. So we're definitely looking into doing that. If that's something that could be useful for you, if you want to automatically access a Cassandra cluster, we're happy to actually start looking at that. Secondary indexes possibly as well. Huge chunk of resources. These slides will be online. Thank you for listening. We won't go through the internals, but if you want to actually try this on your machine, you can download this VirtualBox image using Vagrant. You can play with this on your local host, including like a Mac or a Windows machine. But if you really want to do this properly, do this on Amazon and use the AMI that comes from DataStax. It's really, really easy to get started. All right, so thank you. If you have any questions, you can ask them. Oh, we don't have time for Q&A? So I'll be right at the back. You can ask me questions, or you can email me. Thank you for listening.